Nature abounds with events that are cyclic in their occurrence. These reoccur without any let-up at fixed intervals. Recurring in such a rhythmic cycle are the days and the nights. Cyclic in their onset too are the various seasons. The oceans that cover nearly 2/3 of the Earth's surface also experience a recurring event. Here each day, the level of ocean waters falls, only to rise again, gradually flooding the regions close to the sea. And then it recedes. This cyclic rise and fall of the ocean waters is known as the tide. The phenomenon of tides has been studied since ancient times. Roman naturalist Pliny, in about 100 AD, and later astronomers had noted that in a lunar day which averages 24 hours and 50 minutes, the water level of the oceans rose and fell twice. The rise in the water level was the highest during the new moon and full moon periods. But they could not explain the relationship between the moon and the tides, until Sir Isaac Newton provided his now famous law of gravitation in 1687.
The Newton's law of gravitation states that all objects in the universe attract each other with a gravitational force. And this force is directly proportional to the product of their mass and inversely proportional to the square of the distance between them. In other words, the greater is the distance between two objects, the smaller is the attraction, and the larger the objects, the greater the attraction between them.
In the solar system, the Sun has the largest mass, but it is 390 times as far from the Earth as the Moon. The Moon, though much smaller than the Sun, is closest to the Earth. Therefore, the Moon's tide-generating force on Earth is twice as great as that of the Sun. It is this gravitational attraction and the centrifugal forces that result in what is known as high tide and low tide.
But the gravitational pull of the Moon on the Earth is not uniform. It varies in relation to the distances between the Moon and the various parts of the Earth. The ocean waters on the side of the Earth facing the Moon are the closest to it. Therefore, these ocean waters get attracted by the Moon's gravity most strongly. As a result, the waters here move towards the part of the Earth that is in line with the Moon, forming a bulge that is referred to as high tide. On the opposite side, the solid Earth is closer to the Moon than the ocean. Therefore, the Moon pulls the solid Earth more strongly than the ocean, causing ocean waters to bulge out into another zone of high tide. This movement of water into regions of high tides results in two zones of low tides midway between the high tide locations.
Tides pass around the Earth in tune with the motion of the Moon. Therefore, every point in the ocean experiences a high tide and a low tide every 6 hours, 13 minutes. This is the Kadalundi estuary in Kerala. It is 6 a.m. and is low tide now. The ocean water has receded. Large parts of the estuary stand exposed. And a high tide is about to set in. With every incoming wave, the water level begins to rise slowly. The rising waters gradually invade the dry regions of the estuary. once the low-lying areas get flooded, water begins to invade the mangrove regions and the adjoining high-rise sandbanks. This goes on for about 6 hours. By 10 minutes past 1 in the afternoon, high tide has reached its zenith. The estuary is no longer dry. It is now a vast expanse of shallow waters. The rise in the level of sea waters during high tide influences the coastal ecosystem in many ways. Mangroves, for instance, require both fresh and saline waters for their growth. This requirement is amply met only in estuaries where fresh waters of the rivers mix with the saline waters of the sea during high tides. The tidal currents help to sweep out natural navigation channels and harbors and keep them deep. During high tides, the water level rises in the shallow man-made channels and ports. This helps cargo ships and steamers enter into such channels, for at that time there is deep water to float there. High tides also create certain problems. The problems of silt deposition on riverbeds and the problem of an increase in the salinity of river waters.
The fresh waters of the rivers become saline when the seawater intrudes into them during high tides. If the salinity of river waters increase beyond 3 parts per thousand, it becomes unfit for drinking. The extent to which seawater gets into rivers depends on the level of the river in relation to the level of the sea. Salinity is gauged by using instruments such as a salinity temperature meter, which measures the saline content of waters directly from the depths without analyzing water samples.
In this river, about half a kilometer from the sea near Kochi, the salinity is a high 28 parts per thousand. As one goes upstream, the salinity decreases. About 7 kilometers from the sea, the salinity is still high due to an extensive intrusion of seawater into the river. Such extensive intrusion occurs when the high tides are particularly high due to the combined gravitational pull of the moon and the sun.
Though the gravitational attraction of the sun is much less, it does contribute to the phenomenon of high tides. During new moon and full moon, when the sun, the moon and the earth are in a straight line, the attraction of the sun, though relatively small, gets added to the attraction of the moon. This results in high tides that are particularly high, and these are called spring tides. At other times, when the moon, the earth and the sun are at right angles, the high tides are usually the lowest. Such high tides are called neap tides.
The difference in the water level between successive high and low tides is called tidal range and is measured by using instruments known as tide gauges, which are installed on the seacoast. The float of the gauge moves up and down as the water level rises and falls. The data of the gauges help calculate the tidal range, which varies from one seacoast to another depending upon the shape of the coast and the depth of the sea. The tidal range in India varies from a low of about 60 centimeters to 100 centimeters on the southeastern and western coasts to a high of over 500 centimeters on the coasts of Kutch, Orissa and West Bengal. Now at Kadalundi, a change from high tide to low tide has just begun. The water level has started receding into the oceans. It continues to flow back for about 6 hours and 13 minutes, by which time low tide sets in. The regions flooded during high tides are now exposed. This is the time for the marine life in the littoral zone to get active. Homes have to be cleaned of the debris accumulated during high tides. The dry spell of low tide provides the best opportunity for many to trek the sandy shores in search of food and perhaps shelter. This molluscan, of course, is not in a hurry. But the hermit crab is by nature a busybody. Its heavy armored body does not slacken his pace. Decayed matters that get deposited on the estuary during high tides serve as food for many. For instance, these tiny crabs belonging to the Dotila species feverishly devour decayed matter from the sand and gurgle out clean sand in the form of balls. Often, these assume intricate patterns on the shore. The mangrove ecosystem's inseparable part are the fiddler crabs, known for their monotonous yet lively behavior. During low tides, the fiddler community comes out in full strength on the dry sandy shores to enjoy life. And that includes a friendly bout too. Water-flushed cliffs and the rocky outcrops are home to many a crab, such as this one belonging to the species Grapsus strigosus. They come out during the low tide to enjoy the sun and a little unavoidable splashing. These vividly colored crabs feed on dead shells and weeds. During low tides, the estuary serves as an ideal place for a variety of birds to return and relax. The birds include the black-headed gulls, the black cormorant, and the herons. For waders like these egrets, however, it is time to pluck food. This indeed is an interesting way of catching fish. Chasing fish into the nets is possible only during low tides when the estuary is low in water level. For these boys and women folk, low tide is the time to harvest edible clams. From the brackish slush of the river mouth, they sieve out tiny clams. These clams are a simple delicacy among the coastal people. This father and son duo specialize in catching a variety of estuarine crabs. As the water recedes into the sea, the fishermen lay their nets across the river mouth. As the low tides begin to end, the nets are brought up with a rich variety of estuarine crabs. These include varieties such as the Scylla serrata, the Neptunus pelagicus, and many other species. These crabs fetch a tidy sum in the local market. Fishing for some is just a matter of diving and grabbing fish with bare hands. Though it looks simple, it is a tough task. Those who dare to use this primitive but effective method are well rewarded. During low tides, as the submerged reef beds are not too deep to reach, hardy fishermen collect green mussels, for which there is always a demand. These mussels are just another example of the rich variety of marine food that a low tide especially yields. Six hours have passed since the low tide began to set in. Now is the time for nature to yet again unfold the high tide. This cycle continues unabated, a part of that fragile ecosystem which balances miraculously a rich and varied life.